All right, so I already took a look at delta G, right? We said this was negative for spontaneous reactions. And we took a look at delta H already. Let's take a look at delta S right now. And then don't forget about this negative, right? So if we want this delta G to be negative, right, we actually want this delta S to be positive, because when it multiplies by this negative, it'll give us a negative number. And of course, temperature here is in Kelvin, so it cannot be negative. And so we want this to overall be positive in order to be favor the reaction occurring. And so delta S, if you think back to CHEM112, right, this is the change in entropy. And entropy gets defined as kind of disorder. But really a good way to kind of think about it is the number of microstates, which basically means the number of ways you can organize a system. So for example, the most kind of easiest to think about is going from a solid to a liquid to a gas, right? In a solid, everything is stuck in place. You can't move any of the atoms. And so there's not a whole lot of ways to organize the system. And so there's not a lot of entropy. When you go into a liquid, all the molecules are still touching one another, but now they're actually free to move around. And so now we can organize this system in more ways. And then finally, in a gas, they're just flying around all over the place. And so we can organize a gas in many different ways. And so this one has the most entropy. Another example is the number of molecules. So if you have more molecules, in general, you will have more entropy. And so if we go something from like A, B to A plus B, right, we actually gain more entropy here because we have more molecules and thus more ways to organize the system. And then another example is more freedom of movement. So for example, we learned about cyclohexane, and we know that it's kind of constrained. It needs to have certain bond angles. It can't fully rotate, right? If we compare this to just regular hexane, this is free to kind of wiggle around, move around. And so this is going to have more entropy. And so in general, if you have more ways to organize a system, you're going to have more entropy. We'll see that in organic chemistry, and one good example is the formation of a gas. Anytime you have a gas forming in a reaction, that's a good driver of the reaction because that's a huge increase in entropy.